Question 1. What are the measures for the center of data? Circle them. Well, we know that the mean is the average of our data, which is probably close to the middle of it. Standard deviation is about how close things are to the median or the middle, the center of the data. So this is not the center of data. Mode is the number that shows up the most, and it is not always a number in the middle, so this is a no. Median, it means middle. An interquartile range actually has more to do with the spread of our data. So with the spread of our data, that's kind of telling us how spread out our data is, how far things are from the middle, which actually is exactly what standard deviation is how far the points are from the middle. You could use mode to talk about spread of data, because if there isn't a mode, then you know that the data is pretty spread out, but it's kind of a stretch, so I'm not going to circle it. We already said that median is center of data. An interquartile range also has to do with the spread of the data, because it's the distance between the median and the lowest point right here, and the median and the highest point right here, the distance between those 2 points. So number 3 says find the values for the data set. We're looking for the mean, the median, and the interquartile range. Well, to find mean, we're going to add all these numbers up and then divide by how many numbers there are. So 20 plus 18 plus 30 plus 15 plus 27 plus 25 plus 22 plus 19 divided by 8. And I've already done that math, and I got 22. The median is the middle number. Now, if we're looking for the median, I have to put my numbers in order first. So I'm going to go through and I'm going to find the smallest number is 15. And then my next smallest number is 18. And then my next smallest number is 19. And then my next is 20. 22. 25, 27, and 30. And now to find the median, I'm just going to go from either side and find the middle. It's going to be in between 20 and 22, which is 21. And my interquartile range, so if right here is my median, I'm going to find my lower quartile, which is in between 18 and 19, which is 18.5. And my upper quartile, which is in between 25 and 27, which is 26. And my interquartile range, I'm just going to subtract 26 minus 18.5, is 7.5. Number 4 asks, what does it mean to have a normal distribution? Normal distribution means that your standard deviation curve, which is a bell curve, it looks like this, it follows the 68, 95, 98 rule. Which means that 68% of the data falls within one standard deviation, so right about here, and then 95% of the data falls between 2 standard deviations, so out to here, and 98% of the data falls between 3 standard deviations, so all the way out to here. Number 5, Shania was comparing her Algebra 1 test scores. The scores are 75, 82, 78, 62, 86, and 79. And in semester 2, she scored a 77, an 82, a 95, a 64, an 84, and a 78. You have a box of options over here, And if I'm looking at the question, I see the mean for semester 1 is something something than semester 2. And the median for semester 1 is something something than semester 2. And the blank is the same for both sets of data. So what it looks like I need to do is find the mean, the median, the upper quartile, the lower quartile, the interquartile range, and the range of both semester 1 and semester 2. So let's do that. Semester 1, semester 2. Mean, median, upper quartile, lower quartile, interquartile range, and just our plain old regular range. So in order to find the mean, we're going to add everything up and then divide it by how many there are. So when I calculated the mean, because I already did this part, when I calculated the mean, I got 77. When I calculated the median, I had to put all of my points in order, and I got 78.5. When I found the upper quartile, I went from the mean to the last point, and I ended up with 75. When I looked for my, oops, I'm out of order. That was my lower quartile. My upper quartile, I did the same thing, but with the upper numbers, and it was 82. And my interquartile range is 82 minus 75, which gave me 7. And my range was 24. I'm just now realizing I should probably show you my work for that. So I'm going to show my work for semester 2. So for semester 2, I added up all of my points and then I divided them by 6. So when I added up all my points, I got 480. And then I divided that by 6. And that gave me a mean of 80. For my median, I had to put all my points in order. So I had 64, 77, 78, 82, 84, and 94. And to find the median, I just started at the ends and I worked my way in. Boom, boom. My median is in between these two numbers, which is 80. And then to find my upper quartile, I worked between the median and the end number, and my upper quartile was 84. And my lower quartile, I did the same thing between my median and my last number, and I got 77. My interquartile range is 84 minus 77, which gives me 7. And my range is my highest number minus my lowest number. So 94 minus 64 is 30. So now coming back to the problem itself. The mean for semester 1 is something something than semester 2. So the mean for semester 1 is 3 fewer than semester 2, because the mean for semester 1 is 77, and the mean for semester 2 is 80. The median for semester 1, well, semester 1 is 78.5, semester 2 is 80. So the median for semester 2 is 1.5 fewer than semester 2. And part 3, the blank is the same for both sets of data. So I'm looking at both sets of data, and we have the same value for the interquartile range for both of them. And I'm just going to write IQR. The IQR is the same for both sets of data. Moving on to number 6. Mrs. Smith's class took a test. The following statistics on the grades are below. I'm not going to read it all to you. She realized she made a mistake on the lowest score, and the student's grades increased by 5 points. How will this affect statistics? Well, if we're just changing the score of the one lowest score, and we're assuming that it stays the lowest score, it's still at the bottom, so this doesn't affect our median. Our interquartile range also is not affected because our lowest score still stayed the lowest score. But if we're finding an average, we are going to have a change in the average if one of our scores changes. And because that score went up by 5 points, our mean is going to increase. And standard deviation is about how far away things are from the middle. So if the lowest score got higher, that means the lowest score got closer to the middle. So our standard deviation is going to go down because our lowest score got closer to the middle. And we're done with page 19. There is no quizzes today. All you had to do was watch the videos, and now you've done that, so you're done with today's activities.